Hello. Today I'm going to make a series of videos about trigonometry. It's a scary word. Some students get very intimidated by this subject. Um, it's got a lot of detail, a lot of notation, a lot of things to memorize, and therefore it gives you an opportunity, unfortunately, to focus too much on memorization and on learning formulas, and not enough on understanding deeply what it is that you're doing. And it's that deep understanding of what you're doing that will lead to the strongest math grades and the strongest work in mathematics. So I want to address deep understanding ideas right now in this short video, and I'll try to answer a question. What's the main idea of trigonometry? And my hope is that you will learn what this idea is and keep it in mind as you do all of that detailed work that your teacher will ask you to do. Okay. Trigonometry is about geometry. It's about measuring geometric objects. And so I'm going to start by just having you think about some geometric object that I'm going to make here that it's a polygon. I've made a six-sided polygon, I believe. 1, 2, 3, 4, 5, 6 sides, and it's got 6 angles. And I want you to consider that you could have lots of other polygons that you could draw. This is just one example of one. It's not meant to be a regular polygon with all the sides and the angles the same. You could imagine this is standing in for a number of other polygons I could draw, or even things that aren't polygons. But let's for a moment think of just polygons. This is 6-sided. It could have 10 sides. It could have 12 sides. It could have 3 sides. My question right now is there a way, what is a good way, to approach the study of an object like this, a way that will work for any polygon? Some general approach to attacking this object in a way so that I can figure out as much as I can about it. Here's an interesting fact, something that you might not think of on your own. It turns out that every polygon, no matter what it is, can be broken into a number of triangles by doing something very simple. All you do is you pick a vertex, this is one of the vertices, and connect it to all the other vertices. So notice you can do that. So I've just connected it to all the other vertices, and I've got 1, 2, 3, 4 triangles in this case. And on a 6-sided polygon, you'll always get 4 triangles if you do this. And you might see that if you have 20 sides, you'll get 18 triangles, because if you go through, you'll get 2 fewer triangles than the number of sides. It's not super important right now, but you can notice that. Here's furthermore something else you can always do. In any triangle, it turns out that if you go to the largest angle, the vertex of the largest angle, like in this one right here, if you look, that looks like it's probably the largest angle. It turns out it can be proved pretty simply that if you go to the largest angle, then you can always drop a perpendicular line, a right angle, down from this particular vertex. Now, I don't expect you to do this right now. I don't expect you to learn to do this. Don't worry, I'm not going to make you start to do the thing I'm doing right here. I'd just like you to notice that it could be done. If you go to this triangle, notice this is the biggest angle. I could make a perpendicular down to this side, a right-angled line. If you go to this triangle, it looks like this is the biggest angle, so I could make one right here. And this one, it looks like this is the biggest, so there's a right angle. Now, other polygons you make might have the biggest angle in different places, but I want you to notice you can always do this. And what this means is that I have just taken this triangle, this 6-sided polygon, this hexagon, and if you look at it in a certain way, if you look, I have divided it up actually into 1, 2, 3, 4, 5, 6, 7, 8 triangles, 8 little triangles, and they are all right triangles. I'm coloring them in different colors just so you can really see it. Going to the other ones because it makes a pretty picture. Blue one there, I'll make another blue one right there, let's say, maybe a red one right here. Go with brown on this one. Colors aren't important. But I want you to notice, interestingly, any polygon that you ever make can, through this process or other processes that we define, it can always be divided up into right triangles. It's foolproof, never fails. Everything can be broken up into right triangles. Now, why am I showing this to you? Trigonometry is not just about this idea, but I want you to notice something out of all of this. Here's a fact. Every polygon can be broken up into right triangles. Just not write the word triangle, but I'll just write that. And here is the next step in that somebody would take if they were first trying to ask the question, how do I study polygons? They might think, you know what? In order to study polygons, it would be good to just study right triangles. Because if I can understand everything possible about a right triangle, then when I have some object that isn't a right triangle, I can break it up into a right triangle, and I can use my understanding of right triangles to understand things about these non-right triangle objects. So here is my answer to this question. What is the main idea of trigonometry? It is that we will learn everything that we can about the side lengths and the angle measures and other measurements in right triangles, because that will lead into a deeper understanding of all shapes. So the answer is that it is a study of the angles and side lengths and other measurements, like area, for example, but mostly side lengths and angles, in right triangles. Since all polygons are made of right triangles. In fact, here is furthermore an important idea that comes from trigonometry. Here is a key idea. It's that every geometric object, I made an example of polygons, but it turns out every geometric object to some extent can be thought of as being made of just right triangles. So trigonometry is the study of those so that we can understand more about non-right triangles and about other kinds of objects. The second video is going to give you some details, so I encourage you to go to that one.